right, welcome everybody. I'm Lucian Fogoros, and today we're talking about connectivity in industrial IoT solutions. And with us, we have a subject matter experts from Sony Israel, Dima, Feldman. Welcome to IoT World community.
Oh, thank you, Lucian. It's very nice to be here. Thank you for the invitation.
Appreciate your time, getting a little bit of clarity. Now, the way we got connected is during your new launch of the a new chipset, which it basically indicated that it completes the Sony's IoT solution portfolio. In there, you also mentioned is 5G ready. Maybe a good question to start for our community is, what does 5G ready for this new chipset mean?
Oh, the way 5G is built, and it could be confusing for some, 5G means many things. For many of us as a consumers, 5G typically means ultra broadband, which is very high-speed browsing, video downloading, and this is where 5G came up with new radio standard and building some new antennas and towers. For IoT, 5G means millions of devices per square kilometer. Really high density of the devices. It's called massive IoT. And the existing standards of NB-IoT and CAT-M perfectly fit into this 5G vision, and therefore has been adopted by 5G as a physical layer and a network layer for massive IoT pillar of 5G. And this is why what we're doing today is actually 5G ready or even 5G compatible and here to stay with the 5G technology for 10 or 20 years from now at least.
Got it. So just to summarize, the three pillars: ultra low band is the power consumption, the low power consumption. What was the third pillar? I'm sorry.
No, for the 5G, the three pillars are enhanced mobile broadband, which is high throughput, ultra low latency, which is mainly for vehicle to infrastructure and vehicle to vehicle, and massive IoT. And we are playing in the massive IoT field. And the solutions we launched today are really, going to stay in field for. Actually, we have one customer asking for 20 years now. We could even find batteries that guarantee 20 years. I found one battery with, which says 40 years of operation, which is absolutely crazy. So cannot promise 40 years, but 20 years.
So you're looking at a battery for 20 years. I just want to be clear for that, right?
We are looking, to build a product that stays in field for 20 years, you have to have a connectivity technology which stays for 20 years, a security solution which will last for 20 years, and a battery that can support it for 20 years. And now I'm, when I'm going and shopping for those special batteries, some of them would say, expiration date 2041. It's crazy. It's a crazy number.
So I started my career with PC-based control software. Later we merged with a company, but essentially we were following the Intel embedded roadmap, right? So the chipset had to stay around for, longer than the normal chipset. And I thought 7 years was long, but 20 years, 40 years, wow.
No, so I'm not trying to claim for 40. It's actually, it has to be proven, and also technology and connectivity technology should be there for 40. But if you think of critical infrastructure or a metering solution, and when somebody puts an electricity meter in your house, they're not willing to replace that every 5 or 7 years. And therefore, you will see in the specs requirements for which varies between 10 to 20 years now.
Got it. Thanks for that. And now I want to pick up on one of the comments that you made, which was the massive IoT. And if you could put it in the context for our audience, what applications should we see from the massive IoT? Just maybe 2 or 3 applications that you see that these are great for adopting for industrial IoT.
Yeah, I think it's not just industrial, but I think it's mostly not consumer, but could also be consumer devices. I think one very traditional field is utilities, where we connect those gas, electricity, water, or heat meters. Now also in North America and Europe, in some parts of Europe, you have to do sub-metering. So if you consume heat within your apartment, then you want to pay your bill according to your consumption and not an average of the entire building. So there are more and more such meters for billing and also monitoring the system, making sure that you're getting the electricity quality is good, that in your neighborhood the voltage is correct. They can even detect certain fails in the grid. And this is maybe one segment. The other segment is logistics, and we see more and more services and packages and pallets and containers coming with tracking solutions. And if you think of a warehouse, you could probably find many, tens of thousands, hundreds of thousands of items within a warehouse. It's a very high density of cellular devices. If you think of people, we typically talk about few hundred, few dozens of hundred people making phone calls simultaneously. And we know in stadiums, they always bring antennas when there is an event. And now for IoT devices, you could easily find hundreds of thousands of devices in a warehouse. And you need to communicate with all of them. And we also see this growing into building management, city management, smart lights, garbage collection. Like again, part of the maybe smart cities. And also, I do anticipate to see much more in people monitoring, health monitoring things, mobile health devices. Not a huge, I wouldn't see a huge density there, but the number of use cases is so big that across each vertical you could find hundreds of possible devices, all of them, within the same building, and then you need to be able to serve all of them. So very interesting.
Thank you for the insights and the application. Sounds like quite a wide spectrum of application, from warehouses to logistics to smart cities, smart buildings. Certainly lived in apartments that you paid in bulk, but also lived in apartments that was very well segmented. So look forward to the implementation. That's and I guess wide adoption for that. One, you talk a lot about the power consumption, and maybe can you elaborate why is that important?
Absolutely. If I look, maybe two perspectives. One is, and this is very easy to show, if I'm looking on a water meter, there is no electricity there. So when I plug it in and monitor the water, it's all done from the battery. And obviously, we will not have a huge battery connected to the small power water meter. So in order to guarantee those 20 years in field, you have to be very low power. This is one use case. The other use case is lower cost of installation. We have seen devices in the vehicle. Typically, we could connect a tracking device within the vehicle to electricity system of the vehicle. But surprisingly, the device that costs only $20, you will pay additional hundreds for the technician to connect it properly. And if it's battery operated, you save that money. And a third point would be, I would say, totally new use cases. One could be like meters, where you want to put a temperature sensor within your building, in a sensitive point, or next to your fridge. And if you don't have an electricity point, then you will not put it. But if it's a battery operated, then you could have much more sensors. And also for even some commercial use cases, maybe a good example is a pet tracker. It's a small tracker you put on the collar of your dog. And if the dog gets lost, then you can find the dog. If you have to charge this tracker every 2 days, you're not going to use it. If it can last there for 6 months, then it's a great product. So totally different user experience.
Thank you for that. So in closing, I know you've referenced some connectivity for the chipsets. Anything else planned in terms of IoT connectivity, Sigfox, or anything else?
There are many interesting developments, but we are focusing on CAT-M and NB. And for us, the main reason is that cellular network, as it is defined and known by all of us today, exists practically everywhere. Every place I go, there is a cellular network today. So all other technologies requires either inspection if there is a good signal in the neighborhood you want to install. In many cases, you have to install your own antennas. we think those are great technologies, but not built for massive IoT.
Got it. Dima, thank you so much for the insights, and hopefully we can meet at an event soon face to face as the world opens up.
Yeah, I really wish so. Yeah. We are eager to see our partners and especially customers. Not seeing customers for so long is not great for business.
Yeah, we were just attending the Hanover Messa Digital, of course, and it was quite a different experience. We tried to subsidize that or change that a little bit, adding the Clubhouse experience, and we had actually a discussion on 5G with some of the experts. They were in Europe. Actually, they do a large test bed site right from the Hanover Messa. They call it the largest in Europe, but anyway.
Yeah.
So yeah, look forward to see you at an event. Appreciate it. And if you're in the audience and you have questions for Dima or other folks in his team, feel free to leverage the hashtag IoT World. You also see there on the display, and we'll put a link for more information on this ALT1255 chipset, if I pronounce it properly. Thank you so much for that, Dima.
Yeah, it's absolutely proper, and thank you for the invitation. It was a great talk.